last answer is okay, you can check it. Okay? So we continue the next one. The next one. The next one is the geometric representation of complex numbers. What's the meaning of this one? Okay, if z equal x plus iy, we know this one we can obtain. This is the real part. This is the imaginary part. So, if we say this one is a real axis, this one is an imaginary axis. So, if z equals x plus iy, if x is here, so y is here, this is x, this is y. So, we can say this point, this is a point. This point is z is x plus iy. We can also say this point is x, y. So this true, the same. This true, the same. So if this point, if z is this point, so this z is a point, not is a number, is a point. If z is a point, then we can say z is also a vector. Okay? Yes or no? If z is a point, then also is a vector. If z is a vector, we know. I take that color. Okay, we know the laser, this is the laser of this z, we say is the modulus of z. Yeah. So if this is x, this is y. Yeah. So the modulus of z is x squared plus y squared and root. Yes or no? Yeah. Okay, so this is x, this is y. Yeah. So this is x squared plus y.
That is the norm of z.
Okay.
Yeah.
This is the laser.
Yeah.
Okay. If we want to know the direction, this is the direction. If we say this one is theta, if this one is theta, so this theta is the direction of this vector. Okay. If z in this continent, we know theta we can write arc tan y about x. Is it no? And we can also say if this theta is the direction of this z, So theta equal arctangent y above x.
Yes.
We can also say this angle is also the direction of this z.
Yes.
So we can also say theta equals this one, theta also equal this one plus 2k pi. And k equals 0. And so on. If k is 0, it's this theta. If k is 1, it's this big theta. If k is 2, this big theta. 2 circles, then theta. Yes or no? 3 circles, then theta. So,
K is always constant.
k is what?
It's always constant.
Yeah. Understand?
Yeah.
Any question? Okay. So, if this is theta, this is the modulus of z. The modulus of z we write r. If we write this one as r, so we can okay. This is theta, this is r. So x, you can write r multiply cosine theta. Y, we can write r multiply sin theta. So this z, just now you say z equal x plus iy. If we put this one into this one, so z we can also write r cosine theta plus I r sin theta. If we make this r outside, multiply cosine theta plus I sin theta. So this form is the triangle form of z. This form is the algebra. How to write algebra? L G B D G, yeah. B E A. It's not algebra form. Yeah. So this is the first form, this is the second form. Okay? If I tell you Euler formula, do you know Euler formula? Euler? Yeah. Formula.
Yes.
What is Euler formula? Is cosine theta plus I sin theta equal E I theta. Do you know this one?
Yeah.
No. So please remember.
Yes.
Remember. If we write cosine theta plus I sin theta equal E I theta. So we can also write this z in r multiply E I theta. So this is the third form. Which form? Exponential. How to write?
Exponential.
E-X-P-O-N.
Yes. Continue.
E N T-I-O-N-A-L. Exponential? I'm sorry.
Exponential. No.
No.
It's
How to write?
It's okay. T-I-A-L. Yeah, it's okay. Then delete
T-I-L.
T-I-A-L.
A-L.
Yeah. That is explanation.
Okay.
Yeah.
So this is the algebra form. This is the triangular form. This is the exponential form.
Yeah.
But what is this I? What is this theta? Do you know? R is the modulus of z. Theta is the argument of z. So this theta, we say this theta is the argument of z. Argument, do you know? A, R, U, I'm sorry, no. G, U, and E, and T. I say this R is the modulus of z. This theta, not only one angle. There are so many angles.
Yes.
Yeah, there are many angles. We say this angle is the argument of z. Argument of z. This is the argument of z. So, for example, okay, for example. Okay, if z equal 1 plus I, this is the algebra form. I want you put this form into yeah. I need you write this one into this form. Can you write?
Cosine.
Yeah. So you must computer
Cosine.
R and theta. Yeah. Yes or no?
Yes.
Yes or no? In Chinese is 对吧？对吧？ So R is the modulus of z.
Yeah.
So how to compute modulus of z?
Square root of x square.
Square 1 square plus 1 square.
I square. Yeah.
So
Equal to
yeah.
2. Yeah.
Yes or no? Finish.
2i.
No I.
Two
No,
I
yeah, it's
square.
finished. Yeah, it's finished.
It's finished. Yeah, it's finished. Because we can add I when it is negative.
R is a real number.
Yeah.
Theta is also real number. Any question here?
No.
No. So how to compute theta?
Theta.
Uh,
Theta will be equal to arctan.
arctan
Arctan. Yeah.
theta equal arctan 1.
1. Yes.
Arctan 1 is
Equal to 45.
pi
5.
about
5.
About 4.
4. Yeah.
4. Yeah.
Pi about 4. So no? So you can write this pi about 4. You can also write pi about 4 plus 2k pi. But we only need 1. It's okay. So you write pi about 4. It's okay. Understand it? Yes. So Z you can write R E I theta. Understand?
Raushi. For their on Afghan one, what if we can use instead of of writing at that, then you write.
You can understand this one?
Yeah.
You can picture it. Z equal 1 plus I. So x is 1. Y is also 1. Yeah. So this point is 1 plus I. You can also say this vector is 1 plus I. So this is 1. This is 1. So this is enough. So this is 1. This is 1. This is 45.
That's what I'm saying.
45 is pi above 4.
Yeah. I'm saying.
You say
We already know that tan is equal to sine over cosine. Let's say we have an x like tan inverse.
yeah.
Right?
Yes.
Yeah. If we put this like this sine inverse.
This one no problem. This one also no problem. Yeah. So no.
See if we can also use this word, basically this one.
Yeah.
To define the class.
Yeah. Yeah. So if theta is the element of Z, there are many values. Okay? But in all these values, only one value satisfies all these theta. Only one satisfy what? Satisfy theta more than minus pi, less than or equal pi. If theta satisfy this condition, we say this element, this theta, is the rising element of Z. We denote the small a R G of Z. So the small element of Z equals theta. This theta must satisfy this condition. So just now you say theta is pi above 4. This theta is the principal element of Z. But if you want to compute all the elements of Z, you can write the principal element of Z plus 2k pi.
2k pi.
Yeah. So if you can compute this one you can also obtain.
Yeah.
So how to compute this one? Maybe this is not very easy. If Z like this one, this is very easy. But if Z is not so special, how to compute the principal element of Z? So this is very important. Okay? tell you how to compute the principal argument of Z of all of Z. The first one, if Z belong to real axis, for example, okay, if Z belong to here is a positive real axis, here is a negative real axis, here is a positive imaginary axis, here is a negative. So I say, if Z in this positive real axis, please tell me the principal argument of Z is what? If Z is here, like this point, the principal argument of Z is what?
Argument of 0 equals to
For example,
argument of 0.
if here is a 5, okay? I want to know how to compute 5, the principal argument of 5.
That will be equal to argument of 5 plus 2.
So x is 5, y is 0.
Yes.
Yes or no?
Yeah.
X is 5, y is 0.
Yeah.
So 0 above 5 is also 0.
Yeah.
So arctangent 0 is 0.
Yeah.
Yes or no? So if Z in this positive real axis, the principal argument of Z is 0. Any question? Any question here? Okay, the second one. If Z belong to imaginary axis, but is positive here, if Z is here, the principal argument of Z is what? For example, if Z is 3i, 3i is here, isn't it? X is 0, y is 3. So this point is this vector. If this vector, we know the principal argument is pi above 2. Yes or no? Any question? If Z is here, the principal argument of Z is 0. If Z is here, the principal argument of Z is pi above 2. If Z belong to here, is this angle.
The same.
So, is a pi.
Negative. To be negative. Negative 5.
Negative 5. Because we need to satisfy this condition. So pi is inside, but negative pi is not inside. So we need to take pi, not negative pi. Okay. If Z is here, this Z here. For example, minus I, minus 3I. Can you take this angle for him? For this one? No. Why? Because this angle is too big. It's too big. It's not satisfying this condition. So you can't take this one. You need to take this one. So this one is 3 pi about 2, but this one is minus pi about 2. Understand it? So if z belongs to this part, the principal argument of z is minus pi about 2. Understand it? So again, if z is here, it's 0. If z is here, it's pi about 2. If z is here, it's pi. If z is here, it's minus pi about 2.
Oh, yeah.
Yeah.
So means that if it is in x-axis for negative side, it becomes pi. Okay. If z is in negative side of x-axis, it becomes pi.
Yeah.
Then if it is in negative side of y-axis, it becomes negative pi over 2.
Yeah, minus pi about 2.
Yeah.
Yeah.
And if it is in positive side of y-axis, it become
Pi about 2.
pi over 2.
Yeah.
Then if it is in the right side of x-axis, it becomes 0.
Yeah. Right side.
Yeah.
Yeah.
Okay.
Okay. Understand it?
Yeah.
Okay. The next one. Okay. I need to go to take part in a meeting. So please have a rest for 30 minutes.
Yeah.
Okay. Then after 30 minutes, I will come back.
Yeah.
Okay.
Yes.
So you can renew this knowledge.
Yes.
And I will come back here after 30 minutes.
Okay.
Okay. I'm sorry.
Yeah.